Good morning everyone, and today we are going to start we are going to deal with the unit 5. Unit 5 is about the device discovery management, where various devices are going to be discovered by the IoT system, and later they can be configured, then settings can be changed, and as per the requirements, like the type of the sensor, the type of the actuator, okay, the configuration can be changed. Under the title of device management system, we are first let us study device discovery management. Under that, capabilities, okay, then registering a device, then deregistering a device also. Let me brief in the beginning itself about discovery capabilities. Discovery capabilities in the sense, say the type of the signal, for example, analog signal or digital signal. And the capacity, that means a serial port or a parallel port, nature of the data, whether it is serially transmitted and received, or whether it is parallelly received. So that is the example of device discovery capability. The second one, registering a device. Registering a device has to do with like, for example, login. The person has to register with the system and get the credentials, so that the security is met. Security concerns are being met. Otherwise, what happens? Any eavesdropping, like stealing the data, may occur. Then, so the person or the device wants to get the services, has to first register itself with the system, and at the end, let me go for the deregistering a device. So at the end of the business or end of the transfer reception, the device has to deregister. So these mechanisms are going to be studied. The next one is cloud services. Cloud services, in the sense, it is going to have a introduction to the cloud storage. As per the various storage models are there, NAS is there, SAS is there, so many things are there. And there are some application program interfaces also, which are known as APIs, which belonging to the communication domain, related to the web server. Communication APIs, web server, we are going to study. And there is a design, particularly customized design for IoT paradigm, the web server for the IoT. This we are going to study. Then we are going to have device discovery. We are going to start with the device discovery. The device discovery definition says that the wireless gateways, again gateway, we need not deal with the gateway. Gateway is an interface between one network to the another network. A huge network and a small network can be connected with the gateways. Wireless gateways support a key feature known as device discovery or universal plug and play. In short, it is known as UPnP, which allows universal plug and play capable devices on our home network to automatically discover each other's presence and begin sharing data. in the range, in the vicinity, permissible range, say for example 10 feet for the Bluetooth or 10 meters for the Wi-Fi, which is having enough capability, enough power transmission capabilities. So whenever a device comes into the vicinity within the range, so it should be automatically discovered, and okay, the discovering system should discover its presence and start sharing the data. So this particular mechanism is known as device discovery. Let us now go for the registering a device. First of all, why we need the registering a device? A device is registered during the first synchronization of the device. First synchronization. First, it is something like first time we come across a person, like cognition. Then the next time when we visit a person, it is nothing but a recognition. Cognition and recognition. Like that, first time when the synchronization is going to occur, okay, the registration takes place. The sync server will allow users to register multiple devices with the same user ID and password. Okay, that means a sync server, there will be a server which is going to allow a user to register on multiple devices are possible now. Okay, as you may be aware of multiple device login, like for example Amazon Prime or Hotstar or any other streaming system allowing 4 or 5 screens simultaneously. That means one registration or one login ID can be used for 4 or 5 screens. One screen, for example, the mobile the person uses. The second one maybe his laptop. And the third one maybe his television, digital television, which may be in his workplace or in home. So like that, he may share with his friends also. Okay, provided he gives the permission by the means of a OTP or a passkey example. Okay, so this way multiple users, multiple devices with the same user ID are possible. This is how I told you the application of multiple user ID. Okay, it is a really a good feature. Otherwise, the user may feel little bit uncomfort when he wants to change his device from mobile when he is in such a type of environment where he will not be having a television or a laptop. Then when he goes to his office or a home, the the laptop and the television are going to come into the picture. So multiple synchronization, multiple registration of the devices is necessary. Registering a device involves classifying a device as a device type, giving the name for a device, providing the device information. Okay, there are 3 things. The device type, when we say, like as I said, it may be a handheld portable device like a mobile, any make, any model. It is having its own ID, device ID. So the type of device is nothing but it is a mobile category. It is a notebook capable type, like notebook computer type, in the sense it may be a tab, it may be a laptop. Okay, so this is the second type. So the third type is a television. Television is a fixed one in the home or office. Okay, so this is third type of the example for the device type. Giving the device a name. A particular name can be given, name has to be given to the device so that the messages will be displayed properly on the screen. So the user which device he is able to connect or which is choosing and he wants to disable the device, for that a name is necessary. Otherwise, some technical device ID, if it is displayed, the user will not be able to identify the particular device type, device name. Then providing the device information. Device information is nothing but again its transreception data rate, its screen sizes, its operating system, so on information which are necessary for the synchronization server to handle the device properly. For example, I tell you, whenever a big television, 55-inch or so on, television is connected to the device, for example, a router, a wireless router, the router will come to know, and the device also comes to know the speed of the internet, and the device may switch to the data saver mode because huge amount of more amount of data is being fetched from the television as compared with the mobile device. So to have this particular data saver mode on, mode switching, or some settings are automatically changed depending on the device information. So that is how the device information is necessary. The next it is then we provide a connection token and accept the token that is generated by the IoT. That is generated by the IoT platform. Okay. Example one is example for this particular device synchronization is an Uyala player. Uyala player version 4 is a next generation video player that provides an engaging, personalized, responsive, content aware and robust video playback experience that is consistent across the devices and platforms. Of course, the paragraph is self-explanatory, which describes the Uyala player. But anyway, let me tell you about the meaning of some specific words. Engaging. Engaging in the sense there are some features like buffering, okay, and background downloading, and there is a jerk-free rendering is provided. This feature is known as engaging. The particular player is completely engaged to satisfy the requirement of a viewer. Then personalized. Personalized, the meaning of personalized is nothing but the theme. Nowadays, you may observe personalized like lights mode on, dark mode on. Dark mode on in the sense only the player area will be playing the movie or the video. The rest of the screen is blacked out to avoid the eyes or the attention being disturbed by the other screen area. So this is a personalized feature. The second personalized feature is nothing but the resume feature. The player where he has paused in the earlier playback, this is another. So now if you want to play directly at that particular timeline, the player begins that particular movie. So this is stored in a log file depending on the name of the movie, the timeline, the name of the movie and the timeline. This way the log file will be there from the movie being played from the list. This is another personalized feature. So such personalized features will be there in the Uyala player. Responsive in the sense the volume control depending on the sound what you can say feature of the room. So better example is the brightness and the contrast of the screen or the playing area should be adjusted with the light, ambient light. So this is responsive. So this is meaning of content aware. Content aware is really a little bit a difficult feature, but anyway, some players are having, so Uyala is having content aware. Say for example, content is having a racing car, so the player is aware of such fast moving images, or you can say the video is being played, so it should be the rendering rate should be adjusted properly. And robust video playback experience that is consistent across the devices on the platform. Robust in the sense it should not get stuck up in the middle, creating some annoying situation. Uyala player version 4 for HTML5 is a web-based player. He is now introducing it. What exactly it is? Based player that runs on popular browsers across the desktop and mobile devices. So it is made for both. What he is trying to tell is, it is not only made for the desktop, and it is made for the mobile devices. So the authorization or the registration process is being explained by this particular flow diagram or the flow chart, you can say. In the beginning, the token authorized for the Uyala player, token is being generated and transmitted. Then the second step is request for the license for the device. Licensing is again another feature to avoid data intellectual property right. Licensed means he is permitted to use the particular content. So licensing is requested for the device. The third step, the device already registered for this viewer. It's a question asked. In no case, it will go to the fourth step where device unit for the viewer already reached. Again, there is a decision making. One is yes, another one is no. Okay. In case of yes, the next sixth step is followed, where attempt to deregister some device is being done. Then the viewer seventh step, the viewers deregister the limit already reached or not. These are some processes, whether the expiration has occurred or not, whether particular monthly or annual subscription rate is provided or not. These particular tasks are being taken. In case of no, auto register new device, then the ninth one is issue license for the device. So this is the way how the process of registering the device occurs. The next one is example 2. We have a player where what you can say, the class diagram is explained how the things go between the client and the registration service. The client will be there and the device registration service will be there. Okay. Attach the server. It is self-explanatory itself. Attach sender with the content, the data is sent is sender information, the registration, and the tenant ID is being sent. Then in the 2.2, it will reverse back from the registration device to the client. The attach with the receiver, registration, and tenant ID are being sent back. 3.1, there attach receive and registration and tenant ID, then reply to is being again sent back to the device registration service. Okay, then again it is replied back to the client with the information of sender, registration, and tenant ID, as well as reply to address. Okay. After this, this is nothing but the connector, the device registration service. Device registration. Then we shall go for the register the device. Okay. So this is the case when the success has occurred. Successfully the device is being registered. But it occurs between the client and the device registration service. From the client, a message is transferred with the content registration tenant and the registration and the device ID and the metadata. Metadata is the data that describes the data is also being sent. This is all used by the JSON. This will be some JSON body will be there, which is optional. Then adding device will occur. Adding device will occur, and it replies back to the client with the registration tenant reply to and some number, that is again a metadata. Then Amqp is an we shall learn about the Amqp, which is being a protocol being used in this particular scenario. It is advanced message queuing protocol. Is an open source published standard for asynchronous messaging by wired technology. Amqp enables the encrypted and interoperable messaging between organizations and applications. Interoperable messaging, and it is encrypted also for the sake of security. Eclipse Hono is a trademark, which is a proprietary system which provides this particular service for connecting large number of IoT devices to the back end of the interfacing with them in a uniform way, regardless of the device communication. Irrespective of the protocol, the Eclipse Hono provides the remote service interfaces. There are some preconditions one should know. The first precondition is that the client has established the connection with the Hono, and the client established an Amqp link in the role of sender with the Hono using the target address registration along with the tenant ID. This link is used between further registration commands to the Hono. Client established the Amqp link in the role of receiver now with Hono using source registration, tenant ID, and the reply to address. Reply to may be an arbitrary string chosen. Sometimes the link's source address is also referred to as reply to, as the name suggests. This is the address to the request messages. Then registering the device. Clients use the command initially, add information about the new device to the Hono. Each device is registered with the tenant, providing the scope of the device identifier. This operation is optional. Implements the API may provide other means for adding registration information. Example, a RESTful API or a configuration. So this is the Amqp protocol with the protocol stack and various information, the applications, and with the connectivity of the IoT. Version 1, okay, it is having the protocols like HTTP protocol, MQTT, COAP, Amqp1 version, that is just now we studied, and then customer. It is used for the home, it is used for the vehicle, it is used for the household devices, it is used for the healthcare also, and the Internet of the Things, and the traveling. Then it is used for some agricultural devices also. Then other some devices, household devices also, it can be used for the industry, and it can be used for some other areas of the society also. Hono specially supports scalable and secure ingestion of large volumes of sensor data by means of its telemetry and event APIs. Hono's command and control APIs allows for sending commands which are nothing but the request messages to devices, the devices, and receive a reply to such a command from a device in an asynchronous way. Finally, UNO provides APIs for integration with existing device and the credential management systems. Now we can go for the WAMP, that is nothing but Autobahn for the IoT. WAMP, which is widely it is known as, is an open standard WebSocket sub-protocol that provides two application messaging patterns in one unified protocol. It is a routed remote procedure, it is having a routed RPC, and it is falling in the category of the type of the publish and subscribe method of transfer reception. A block diagram where there will be a client and a router, client and the router. There is the session is being explained between the client and the router. The client is having various roles. It is having a publisher, it is having a subscriber, it is having a caller or a callee. And the middle layer, that is the transmission layer, where there will be a transport and a session, both this one processes are possible. On the router side, there are different roles will be there. There will be a dealer, there will be a broker. This is the way how the WAMP protocol starts between the two peers, peer 1 and peer another peer. TCP connection is established first. Okay. Then TLS connection is established at the second step. Then there is a request being sent for the setup of a WebSocket connection. Okay. And the response is given back to. So these two, request and the response, are known as initial handshake. Then WAMP is established and WAMP is closed. So WAMP is established and WAMP is closed. So this is known as a WAMP session lifetime. WAMP established, WAMP. Then again, this is one packet, you can say, one stream, you can say. Again WAMP is established and WAMP is closed for the second session or second chunk of the data or second packet of the data. WAMP established, WAMP closed. Okay. So this such one or two or multiple will be there, which is known as WAMP transport lifetime. WAMP session established, closed, WAMP session established, closed, multiple together known as WAMP transport lifetime. Then after the WAMP is over, all the messages are being transreceived. Okay. Then web connection close, termination of the communication link it is. Then close response will be there. Then both these together are known as closing WebSocket connection. Then TLS connection is broken or closed, and TCP connection also is closed or broken. So this totally it is known as WAMP protocol. Then as we learned just now that this is a publish subscribe messaging method using the WAMP Autobahn. So client and another two clients are there connected via the server. Client process will be having client WAMP application session, and there will be an application code also will be there. In the server, there will be a server process which is running the WAMP router session, and another client similar things will be there like client process, WAMP application session, as well as the application code will be there. Then between the client and the server, there will be a WAMP WebSocket communication will be established. Then message published to the topic. And from the server to the another client, of the end client, there will be a WAMP WebSocket communication again established, and the subscriber receives the message. Message being sent and the message being received by the subscriber. So this is what happens in the publish subscribe. There is a Django, is a Python-based free and open source web framework. Django is a free and open source web application framework written in Python. A framework is nothing more than a collection of modules. There will be different modules. He is saying that make deployment very easy. They are grouped together and allow us to create publications or website from an existing source instead of from the scratch. Already the material will be there, already the earlier website will be there. So from that you can design using Django a web application. That is the feature of the Django instead of from a scratch. Django architecture, it is having a three different modules, you can say. One is model, another one template, another one is view. Model acts as a definition for some stored data and handles the interaction with the database. And in a web application, the data can be stored in a relational database or non-relational database as an XML file also. Django and the methods in a particular type of the data. So the second one is the template. In the template, in a typical Django web application, the template is simply an HTML page with a few extra placeholders like XML, email, style sheet, Java server, JavaScript, and CSS, that is the comma separated values. And the view, the third model, you can say, the view ties the model to the template. It is something like sandwiching. It is a connectivity between the model and the template. The view is where we write the code and actually generate the web pages. View determines the data is to be displayed and retrieves the data from the database and passes to the template. Creating Django project and app. There will be an HTTP request, the URLs, then forward message to the view. View will be another Python program. URLs is again stored in a urls.py. The model, okay, there will be a read-write process between the view and the model. Then HTTP response will be there as a form of HTML web page, and the template will be created. So there is a small box creating a new Django project is being displayed. So that's all for today's this one.